Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem anti-diagonal traversal of matrix. This is a medium level question and it's the problem of the day on Geeks for Geeks today. The company tags of this question are Amazon and Microsoft and the topic tags are matrix. So going through the question, given an n by n square matrix, written an array of its anti-diagonals in top leftmost to bottom rightmost order. Okay, so in an element of an anti-diagonal ij, surrounding elements will be I plus 1 j minus 1 and I minus 1 j plus 1. This gives a very clear cut hint which we'll see later. So look at the examples for more clarity. So these are some examples given. We'll go through them in brief. And the expected time complexity to solve this is O of n into n, that's n square, and auxiliary space is O of n into n. So but the solution that we are going to solve this question will be of time complexity O of n, because we'll be only using 2 for loops, and auxiliary space would be O of 1 because we are not using any extra space to solve this question. They are asking us to return a vector and that's the only vector that we are taking, so we are not taking any extra space, so it's basically O of 1 space, right? So constraints are n goes up to 100 and each value of matrix can go up to 100, fine, starting from 0. So before we proceed further, I would like to mention that I have attested the link to my WhatsApp channel that I've created. So on that channel, I'll be posting updates about the webinars, hackathons, events, anything that's happening, and off-campus opportunities, especially either it might be placement or for the internships or for the people, students from 2023 batch, or maybe before that as well. And also every tech-related, software-related news, and that's going to actually help you a lot in your interview preparation and as well as placement preparation. Okay, so please make sure you actually join that channel and actually share a word about it if you actually like it. So let us go through the question now. So this is the question. So in the question it's been clearly mentioned that written the anti-diagonals, right? Written the anti-diagonals. So that is the reason in this example, if you can clearly see, the output is 3. So this is this 3, and then 2 4. 2 4 denotes this particular diagonal, and then 3 5 7, that is this diagonal, and then 189, that is this 18. So I'll just write this as properly 18, so that is this, and then 9, this is this. So that's the reason this is the output. But if you can put it out in a 2D matrix, 2D vector fashion, that is this is 3, this is 2 4, this is 3 5 7, this whole constitute one thing, and 18 constitute one thing, and 9 constitute one thing. So but this is not what they're expecting, this is what they're expecting, okay, in a single 1D array. That is what we are expected to return. I hope you people have understood. So they're actually asking us this anti-diagonal. So generally diagonal is taken in this fashion, but anti-diagonal in the sense opposite of it. So they are taking in this fashion for each and every particular element. So that is what they're expecting us to return. So what is the thing that we can notice here? Fine. So how do we figure out the approach to solve this question? So I hope you people have got a clarity on what we need to return, but now we'll understand what is the approach to solve this particular question. Okay, so the approach is, if you can clearly see in the question, I was talking about previously, the element, okay, the anti-diagonal element ij as its surrounding elements, okay, or you can say the elements that are part of its family, ij's family, are I plus 1 j minus 1 and I minus 1 j plus 1. So what are they? So family of family of ij is basically I plus 1 j and I minus 1 j plus 1, or no, I plus 1 j minus 1, right? So it's I plus 1 j minus 1 and I minus 1 j plus 1. So what is the peculiarity or speciality about these two coordinates? When you just add these points, what do you get? I plus 1 plus j minus 1, that's actually equal to I plus j. And what is this? The addition I minus 1 plus j plus 1, that's again I plus j, right? And what is the original coordinates addition? That is also I plus j. So what can you observe from this? So the observation is that the family of the coordinate or the particular point that you're dealing has the family members to be that points whose addition or the sum of the its particular coordinates is also I plus j, right? So this all things like I plus 1 j minus 1, I minus 1 j plus 1 belongs to a family ij, right? Belongs to the family ij. So if in the question it would have been asked to return the 2D matrix or the 2D vector as the 2D vector as the result, I mean as a function instead of a 1D vector that's been given in the question, we can happily put all those elements that are actually summing up to be I plus j in the I plus j family. For example, all this particular thing, if you can just extend it to this thing, okay? So I'll be using a different ink for now. So this comes to a family of 0 plus 0. Okay, 3 comes to a part of 0 plus 0, and 2 and 4 comes to a part of what, 1 plus 0. So because what is 2's coordinate sum, 0 plus 1, that's actually equal to 1, and 4's coordinate sum, 1 plus 0, that's actually equal to 1. So both of them come to a part of this, so that is 2 4. Okay, and this is 3. And what's the other thing, these 3, so what would be their family be, that is 2 plus 0, right? 2 plus 0 equal to 2, because this is also 2, this is also 2, 1 plus 1 equal to 2, and 0 plus 2 also is equal to 2. So both will be all these 3 will be coming in the family 1 plus 1, that's actually equal to 2. So this is 1, this is 0, this is 2. So what are all the family members of this, 3 5 7, right? And what is the other thing, this coming to particular this, so what is this addition, that is actually equal to 3, 1 plus 2 equal to 3, and 2 plus 1 is also equal to 3. So that is 1 plus 2 addition, and this is actually equal to 3, and the family members of this would be 1 and 8. And what about this particular 9, so that is 2 plus 2 equal to 4, so 4 equal to 2 plus 2, that is actually equal to just 9, the family is 9. So if you can clearly see, at 0th index we have 3, at first index we have 2 4, at second index we have 3 5 7, at third index we have 1 8, at fourth index we have 9. So that is what it's also given here, right? The same order it is also given here, right? The same order, 3 2 4 3 5 7 1 8 9, the same family, right? I hope you people have understood. This is 0th index, this is first index, second index, third index, fourth index. This would have been the easiest way to solve if it would have, if the function is a 2D vector, right? So you can just directly insert 3 at 0th index, 2 and 4 at the first index, because 1 plus 0, the index sum would be, sorry, their coordinate sum would be the index at which they'll be inserted. So it is a 2D vector. This is approach for 2D vector, but here that is not the case. Here it is an approach for, here they're asking us to return a 1D vector. So the only way that you can do for here is a basic iteration, okay, the conventional iteration. So how do you iterate? So starting from this particular point, okay, starting from this particular point, iterate. So what are they asking? They're asking for the diagonals thing, so just do it. So just like this, okay, the same traversal, okay, the same traversal. Now let us stop here, because we have come to the end of this row. Now you need to do some other use some other for loop or some other thing to come to this particular thing. Now let us first evaluate for this 5 blue arrows. How are you going to do? So at each and every index, take your row to be that particular 0, and column to be that particular I. So I goes from 0 to n. Okay, so it takes, let this particularly, this is 0 comma 0. Now come to this particular thing. What is this in coordinate? 0 comma 1. So 0 comma 1, and what would be the next partner of 2? That would be 6. And what is that coordinate? That is 1 comma 0. So what are you doing for traversing the towards particular partners or to particular family members? Let us assume you are on this particular position 3. For its family members of 3, you are going to reduce the column, so the reduce the column, so that you'll be going to the left, and increasing the row, so that you'll be going to the bottom. So that you'll be getting this. Again, decrease the row, decrease the column, increase the row, so that you'll be coming to this. What is the limiting condition? What is the stopping condition? Where your row will be greater than row should be less than n. Okay, row must not be crossing this particular point, and also column should be greater than or equal to 0, isn't it? Your column cannot go out of this particular boundary. So taking for everything, so considering for every element, you will be considering your row to be, because you're starting from row 0, so row to be 0 and your column to be I, right? Starting from for each and every element. And we'll going to the left side. So how do you go to the left diagonal? Decrease the row, increase the column. This is the formula. But you have traversed all these 5 things. Okay, all the upper triangle part is done, upper triangle of the matrix is done, upper diagonal part. But what about these elements that were left uncovered? All these elements were left uncovered, isn't it? All these elements we haven't covered yet. So how are we going to cover? So this problem starts from row equal to 1, isn't it? So row equal to 0, everything is covered, but from row equal to 1, this problem has come. So start from row equal to 1, go to row equal to n. Okay, start from row equal to 1 till n. So how are you going to start? So all these problems occur at this common place. Now because now you have traversed the whole row, now you need to traverse the whole column. 0th row traversal is done. Now you need to traverse the n minus 1th column. So that's how you, and starting from row equal to 1. So row equal to 1 to n, that's what you'll be going for every iteration, but your column will be the same thing, n minus 1. So starting from column n minus 1, how do you go to the left? Same formula again. Decrease the column, increase the row, so that will be going to this particular position. Okay, this particular position. Again, to get into this particular position, decrease the row, increase the column, decrease the column, increase the row. That's it. So you'll be done with this particular thing. Again, now coming to this, so now your column will remain the same. Column will always be n-1 because this is what you're traversing now, but your row will be changing. This time row equal to 1, this time row equal to 2, this time row equal to 3, this time row equal to 4. Once you're done with everything, your final array is done, right? I hope you people have understood. So if you want me to dry run, so I cannot erase this particular arrows because everything will be erased now. So for this particular case itself, so the answer would be 1, and then starting from 2, that is 6, and then 3, 7, 11, and then 4, 8, 12, 16, and then 5, 9, 13, 17, 21. This will be covered by the first for loop. Okay, first for loop. By the first for loop, we will be getting all these elements. Now coming to the second for loop. So second for loop starts from this particular first row element, first row last column element. So starting from this, so you can just continue from here 21. I'll just write from 21 here. I cannot write this whole stuff again here. Place will not be sufficient. So 21, 10, 14, 18, 22, 15, 19, 23, and then 20, and then 24, and then 25. Okay, so this 21 you can just erase. Okay, I'm just mentioning this. So from here it continues here. Okay, so do not confuse. This will be from your second for loop. This will be from your second for loop. So you can just maintain some position to be 0, and you can do this position 0, position 1. You can just keep on updating whenever you keep an extra element. Okay, so this is a very good approach and optimal approach. The time complexity is O of n plus n. O of n plus O of n, that's actually O of n, and the space is O of 1 because we are not taking any extra space. We are just solving in O of 1 space. Only vector that we are using, that is to return the thing. Okay, so I hope you people have understood this particular approach. And so I've explained two things: what if it's a 2D and what if it's a 1D, right? So that's it for this thing. So let us go through the solution now. So vector int matrix, the matrix that they have asked for, and int n equal to matrix dot size. So first one, int row equal to 0, column I. So this is the upper triangle traversal, upper triangle traversal. So in matrix you'll be finding upper triangle and lower triangle. This is the thing, upper triangle traversal. So there will be like, you'll be starting from row 0 for everything, and column I, column changes. So while row less than n and column greater than or equal to 0 for each and every anti-diagonal you're taking from row equal to 0 and column I. So this is the base conditions. Okay, I mean stopping conditions. And so you'll be result dot pushback of matrix of row plus plus column minus minus. Okay, so you may take first declare a size and then take position 0, position 1 and all, or you can just directly push back. That's completely fine. Like pushback is much more advisable. So and then for int I equal to 1, this is our lower triangle. Okay, this is lower triangle traversal, and starting from int row equal to I, column equal to n minus 1, right? So in this case your row changes but your column sticks to the last column itself. So what's the limiting condition? Again, these are the stopping conditions. So row less than n and column greater than or equal to 0. Fine, and you just push back and finally return the result. That's it. Very easy question, right? So I hope you people have understood. So I've explained the very optimal approach, and I've make sure I've explained everything in a bottom line thing, grassroots levels. Fine, and that's it for this. And codes in C++, Java, Python are there in the description. Please go through them, and also please do consider joining this WhatsApp channel because it will greatly help you a lot. And also in terms of all aspects of software preparation, I am trying to put all the things that are required in well organized and structured manner. Fine, so thank you guys for watching this video. Stay tuned.